All right, your note guide starts off with some words. The very first word on your note guide is two words. The first one's a histogram, and we talked about this yesterday. Let's define a histogram. Going to write that in there. A bar graph that shows the frequency of data values in intervals of the same size. Go and write that in on your note guide. So it's on the front side with the two words on top. Yeah, there you go. So the first word's histogram. Go ahead and write down the definition. A bar graph that shows the frequency of data values in intervals of the same size. I'm going to write that down. I'm going to pass out a. Let's define our second word. So a histogram, we made that yesterday. Remember with the gas prices, the bar graph? We did one already. We already know what a histogram is. It's that. There's a definition. You already did one. Now there's a definition. We also did a frequency table yesterday. Now go ahead and write the definition. See, we actually did one before I defined it this time. So I usually define something, then we do it. We actually did it. Now we're defining it. A table that shows a frequency of data values in intervals of the same size. Rocking and rolling. Sure. Back later, Gonzalez. So yesterday we did a frequency table and a histogram, like I said, and I still have them up here. Remember those the gas prices? Let's see, I think it's right here. Gas price, there it is. Remember the gas prices? We did, here was a frequency table. Look at, we did a table, it's called a frequency table, and then we did the histogram right here. That was yesterday's work. You should have that in your notes somewhere. If not, you can watch the video later. But notice it says intervals of the same size. When I talk about interval, I'm talking about a beginning and an end. Look at, these were all about 10. The width was 10, these intervals. Okay? Interval has to do with a beginning, like a window that has a beginning and a window that has an end. Sometimes there's intervals of money, there's intervals of time. They're like increments of something, parts of something, parts of the data in this case. So the intervals have to be in the same size. Now, look at the middle of your note guide now. We just defined the two words. If you look at the middle of the note guide, you have these three pictures here. Check that out. It's right in the middle. What we're talking about now is, look, the shapes of histograms determine a lot and tell us a lot about the data, believe it or not, the shapes of them. And notice what it says here on your note guide. It says symmetric and skewed distributions. The word distribution is a fancy schmancy word that just means graph of data. Just put graph here. I'll be using that word a lot, distribution. A distribution is just a fancy word for the graph of some data. Like a histogram, we call it a distribution. You're going to see that a lot when you get to college, especially. Some of you are going to Mount Sac or Chaffey. When you take your statistics class in college, you're going to hear the professor call it distribution, not a graph. It's a distribution. The spread of the data, because to distribute means to spread. So now watch. Distributions can look like this. Look at how the bars of the histogram are all the way to the right, most of them, and then they get small as you get to the left. We call this part, when the bars get lower and lower, we call this the tail of the histogram. And the tail is all the way at the left, so we call a histogram that looks like this skewed to the left. The tail's to the left. So go ahead with your marker, your highlighter. Go ahead and highlight skewed to the left, please. I want you to highlight these big words because you're going to use them a lot on assignment 47 and 48. They ask about the shapes. So look at the tail of the graph extends to the left, and most of the data is on the right. Look at these big bars. Most of the data is on the right, and the tail is to the left, so we say it's skewed to the left. As opposed to highlight symmetric. Symmetric means you can chop something in half, and the parts are equal, the left and the right side. In other words, in one sense, you and I are symmetric. If I were to slice you right in the middle of your nose, your left and right side are kind of the same, really, like symmetrical. Anything that can be divided in half. So look at this histogram. If I were to divide it right in half, the left and right side are like mirror images of each other, so we call that a symmetrical graph. Notice. So go ahead and highlight symmetric. And the last one is, notice, skew to the right. The tail is going to the right. Most of the data is on the left. Highlight skew to the right, please. Highlight that puppy. So far, so good. So distributions, which mean graphs, take on different shapes, and it tells us a lot about them. Now, watch this. You guys are doing excellent. Go ahead, actually underneath this now, right where it says the notes, we're going to draw 3 little box plots that are skewed to the left, symmetric, and skewed to the right. What would a box plot look like if it was skewed to the left? Well, the whisker would be longer on the left. The tail would be the longer whisker. For instance, I'm going to draw a little box plot right here. Put the median towards the right and put the long whisker on the left, and then a short whisker on the right. This box plot corresponds and is related to a skew to the left histogram. Notice how the tail is to the left, so it would be with a box plot that's skewed to the left, the long whisker would be on the left. Okay, they're related. How about a symmetric box plot? Look at, it'd be the box, the median would be right in the middle around there, and both whiskers would be about the same size. Notice that. That would be a symmetric box plot. So it's kind of like a symmetric histogram. And you're going to ball me up on Friday? And you're falling asleep? Be ready, I'm going to ball you up on Friday. Ouch. Watch this. Skew to the right. The whisker will be on the right side, longest. And the median is going to be more to the left, and then you got the short whisker on the left. That's a skew to the right box plot. You with me? So they're related, box plots and distribution. They're telling the same story, in other words. You guys are doing awesome. We're almost done. You guys are doing really good for a Wednesday. At least most of you. I won't mention any names, but you know. Flip that page. Flip it. Give me one light, Gomez, really quick. Quick. Just one. We're not done yet. Watch. I'm turning on the lights because I want you to see this board in front of me, or right besides me. Notice. Let's have a seat. You're awesome, Gomez. Measures of spread, there's 3 of them. Range, standard deviation, and 5-number summary. Measures of center, there's 3 of them, mean, median, mode. It just so happens, ladies and gentlemen, it just so happens that the shape of the distribution tells you which one of these to use for the center and which one of these to use for the spread. Remember how a couple of days ago I said sometimes if you have data, the median is a better way to go and the mean is a crappy way to measure center and vice versa? Well, it's related to the shapes, believe it or not. So watch this. On your notes, this is right in front of you. Get your highlighter. If you ever have a distribution that's symmetric, highlight this for me. Use the mean to describe the center, and use the standard deviation to describe the variation. When you see the word variation, that's just a fancy word for spread. Spread and variation mean the same thing in statistics. That's for symmetric. But what if your distribution's skewed? What should you use for the center? Well, look what it says. When it's skewed, use the median to describe the center. Look at not the mean, the median. And what about the spread? Use the 5-number summary to describe the variation. Think about this. So the shape tells you which one to use. That's kind of like the moral of the story right now. And look at what that note guide did something very valuable. You should actually call and thank the publishers for making this so valuable. Look at what they did for you. With the skewed graphs, look at what they did. The more outliers you have, look at, these are all outliers because they're away from most of the data. This mean, look at the mean right here, is drugged to the left. If you have more values going out here that are outliers, this goes to the mean moves to the left. That's the point of this picture. Okay? The mean goes this way, so it's not the center anymore. The median would be the better center. And vice versa. The more your graph goes to the right, the more outliers are to the right, it drags that mean that way, so it's no longer a good measure of the center. That's why you use the median if it's skewed. That's the point of this whole highlighting exercise. Almost done. Cool. You got your highlighter. We're going to do just one example. That's right there at the bottom of your page. It has to do with average annual snowfall in inches of 26 U.S. cities. So you're looking right there at the bottom of your paper, right? You see this? It's got parts A, B, and C. Let's answer these questions together and we're done with our notes. So, the table shows the average annual snowfall in inches of 26 cities. Obviously, I'm pretty confident that one of those cities is definitely not Pomona. Why? It never snows. I'm sure there's probably an outlier year if you Google it, where there was probably some snow, maybe like once every like 20 or 30 years or whatever, but you're pretty confident that you're not going to see this many inches in Pomona, shoot, or Chino, where I live. But, wow, well, I'll tell you later. So, 26 cities. The lowest inches of snow was, you could see, where is it, 10, I think, or 15, huh? Yeah, 15. And the highest would be 95 inches. That's a lot of snow. Anyway, look at what A says. Display the data in a histogram. So we're going to make one histogram today. But before we make the histogram, we've got to make the frequency table. So right above this on your paper, right above this where it says extra practice, there's some space for notes. Let's make the table. Going to make me, doesn't have to be fancy schmancy, 6 rows. Actually 7 really. 1, 2, 3, 4, 5, 6, 7. Let's label this intervals here. Go write intervals. Again, there's a little space for notes right above there. Intervals. Right, the little note section. So I'm going to write intervals on one column, and then I'll put frequency. I'm going to abbreviate frequency, F-R-E-Q, frequency. Remember we did this yesterday, right, Novato? Go Dodgers, come on. Oh no, Alvarez, stop. Here we go. Watch this. The cool thing about this question is they actually started us with the first interval. Look at it, it says beginning with 15 to 28. It's on your paper there. So they gave us the first class to start, or the first interval. So that tells me how wide each interval has to be. 15 to 28, going to write 15 to 28. How much is that? Let me take 28 minus 15. That's a size of 13. So every interval after that better be 13. You have to do it that way to stay consistent. So now the next interval then, here we go, is going to be 29 through, let me take 29 plus 13, 42. So far so good. 43 through, let me take 43 plus 13. Nice. Questions so far? We did this yesterday. Well, I took 28 minus 15 just to see how wide it is. So 28 minus 15 is 13. So then the next interval, I knew that I had to start on 29, and I just added 13 to it. Right? So this way they're all the same size. Oh, they gave it to us. Look at part A. It's right there. They tell us to start there. Good question. Okay, they gave most of the questions on assignment 48 also will tell you, they'll give you the first group to start off with just so you know how wide they have to be. Good question, good question. Rocking and rolling, let's keep going. All right, next one will be 57 through, what's 57 plus 13? I'm just a math teacher, how am I supposed to know that? 70. 71 through 84, yeah. 85 through 98. Nice. Done. 6 classes. Because look at the directions say 6 intervals. We're done. There's 6. 1, 2, 3, 4, 5, 6. Six intervals. We're rocking and rolling. I love it. Let's get the frequency now. Okay, frequency. How often did it occur? That's what frequency means. So 15 to 28, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of those puppies. Go to write 11. By the way, as we're doing this, start trying to envision in your mind how the graph's going to look. Is it going to be skewed or symmetric as we do this? Because after we're done with the table, we're going to draw our histogram, the distribution. As we do this, though, if you're paying attention and focusing, you can already envision how it's going to look. It's skewed left, right, or symmetric right now. Watch. Pay attention. 29 to 42. 29 to 42. Let's rock and roll. Use a different color. 1, 2, 3, 4, 5, 6, 7, 8. 8 of those puppies. Question so far? It's pretty straightforward, nothing too crazy right now. It's not high-level math. It's can you follow directions and focus? That's all this measures in you. 43 to 56 now. 4, let's see. 1, 2, 3, 4, 5, huh? Yeah. Questions so far? $57 to 70, let's see. I want to say there is 1 there. These bars are starting to get small now. They went from big, smaller, smaller. So is that going to be symmetric or skewed? You could start, you already envision it's going to be a skewed histogram. Okay. Would it be skewed to the left or right? Think about it right now. How about 71, 84? There's nothing, huh? That's a zero interval. And the last one's 85 to 98. There's 1 right there, 95. So there's 1. All right, cool. We're done with the frequency table. We're rocking and rolling. We're almost ready now to draw our histogram. Okay, let's see. We're going to find out right now. Questions? I think you're right. I think you're right. Shoot today. Okay. Last step. We're almost done, you guys. You guys are doing excellent for a Wednesday, I must say. No whining, no complaint. I love it. Frequency table. Let's make our histogram now. You put your histogram wherever there's some empty space, because I don't really care. These are your notes. You don't give them to me. So wherever you see some empty space, go ahead and give me a vertical axis and a horizontal axis like I'm doing right now. Watch. Horizontal, vertical. Thank you. Right there is perfect. Awesome. Awesome. So you put it wherever you want on that note guide. Vertical, horizontal axis. All right. How many intervals were there? 6. Watch this. Notice I'm going to skip some space. I'm going to put my first bar right there. I always leave some space here. Please make a note of that. By the way, Dave. Okay, cool. Please make a mental note of that. There's a first interval, second, third, fourth, fifth, 6 intervals. Again, the first one starts right here, so let me label it for, that's 15 to 28. Go right, 15 to 28 here. 15 to 28. That's going to be our first bar. What was the highest frequency? Thank you. So I'm going to go by 2s. So frequency. Frequency is going to be my vertical axis. 2, 4, 6, 8, 10, 12. Rocking and rolling. By the way, what is 15 to 28? Well, let me finish these classes now. So 15 to 28, 29 to 42, 43 to 56. You think I'm going to put this on the quiz on Friday? Should I? Well, I have a whole month because my paycheck just went through my checking account, so I can still abuse you for a whole month. 43 to 56, 57 to 70. I think I'm gonna put it on the quiz because we're gonna practice more tomorrow. So, what do you think about us? Put on the quiz. Thanks. Let's see. 71 to 84. And 85 to 98. We're ready to rock and roll. The rest is a cakewalk. Let's make our bars now. Um, 11 is a frequency. Nice. 29 to 42 is 8. Right, Casas? Phones away, right? Earphones. 43 to 56 is going to be, I want to say 5. Was it 5? Yeah. $57.70 is 1, so that's a small one here. So right there, a small little bar. Empty on 71 to 84, and then one small little bar to finish it off. And by the way, what do these numbers mean at the bottom? Is this 15 to 28 chickens, horses, or termites? What are we counting there? What? Intervals of what, though? What are we counting? Chickens? Nice. Of what? Inches of what? Snow. So put average snowfall, inches. Again, Pomona is not part of these cities. Or Chino. Snow, rain, not snow. Get it right, get it right. Get it right. And for our vertical, I'm going to just abbreviate frequency as FREQ for frequency. And to add like some aesthetics, it's a little eye appeal. You want to color the bars Dodger blue. It's got to be Dodger blue. It's all wrong. The whole histogram is wrong if it's not Dodger blue. So make sure you color in Dodger blue. Okay. It's got to be Dodger blue for the histogram to be appropriate. Okay. By the way, is this skewed? Symmetrical, skew to the what? Right, because the tail is to the right. This would be a skew to the right histogram. Now let's answer the two questions right there on your note guide. B and C, watch. So we're done with the histogram. Let's see what B says. Which measures of center, here we go, and variation. Remember, variation means spread. Which measure of center and spread? Which one do we choose to measure this puppy? Median and? Read your, let's see, let's go back up, you guys. Come on, here we go. Read right here, look at it. We highlighted it. If it's skewed to the left or right, look at what it says. Use the median to describe the center and the 5-number summary to describe the variation. That's the answer to B. It's right there, the stuff we highlighted. If it was symmetric, you'd use the mean for the center and the standard deviation for the spread. Always, yeah. But typically ranges for like simpler data. When it gets more complex, use these two. Not never, I want to say never. Sometimes they'll ask for the range. But these are predominant, these two. Good question. Now, that was part B. So let's see. Let's go and answer that. So part B says, so going to write for center, use median, because it's skewed, period. For variation, and again, variation is just a fancy word for spread. For variation, comma, use 5-number summary. I'm going to abbreviate number, 5-number summary. Forgive my chicken scratch writing. I have sloppy writing. It's actually a sign of intelligence, by the way. That's why you go to the doctor, it's all chicken scratch, the doctors. Nice. Last question and we're done. Here we go. A weather station lists the top 20 snowiest major cities. The city in 20th place had 51 inches of snow. How would you interpret the data? So in other words, how would you interpret 51 inches of snow? Well, let's look at our data. So let's see. 51 inches of snow, the median would be, the center would be about right here, the median. Because look at your notes when you go up here. Look at the medians right here on these pictures on your note guide. The median is close to the biggest. It's like the balancing point. If all these bars weighed something, what would be the balancing point for the whole histogram? The median is always right here close to the biggest bar. So coming back over here to that question, let's see. 51 inches of snow, how would you interpret the data? What would you say about 51 inches? Well, here's what we would say. 51 would be above normal or below normal? 51. So here's normal. The median's right here. That's normal. So it'd be above normal. So that's how you'd interpret it. The 51 inches would be above normal. So let me go back over there. And let's write that. 51 inches would be above normal. Because remember, normal in this case is the median, Guzman. That's what's normal. That's the center. So 51 inches would be above normal. So that'd be a crazy year of crazy snow. If the lowest out of 20 cities is 51 inches, that'd be trippy. I'm giving you 20 good minutes to get some assignments done. I've been looking at some of your guys' grades.